Okay, Jeremy, you slacker. You better be watching this at home now. So, who has Jeremy's phone number? All right, so send him mass texts that he's a slacker and guilt him into watching the vodcast. Okay, so this is 7.4 trigonometric substitutions. No, you're supposed to tell him to watch the vodcast. That was the whole point. You didn't hear that part, right, Alex? Nice. I think we missed the point here. His phone will just blow up. Okay, so let's say we have something like the antiderivative or indefinite integral of dx over cosine squared 2x. Once again, we want to manipulate this a little bit before we start in on doing the antiderivative. Well, you could write this as 1 over cosine 2x squared, could you not? Dx. Is that okay, Mo? Yeah. And then, what could we write this further as? Something we know and love. Well, we could call this, oh, I'm sorry, not 1 over. Dopey me. We could call this secant 2x squared dx. Yeah, you don't like it, but is it easier to integrate is the question. Even though you don't like it, Johnny, is that easier to integrate? Yeah. Well, let's try to figure that out. So then, off on the side, we could say, not that, Jeremy. We could say, let u equal, and a lot of you, I know at this point, would say, let u equal secant 2x. I know, right? You're going to say that. But probably saying 2x is better, because we want to keep the secant part. Even though you feel like in your heart, oh, make the whole thing u. But that's not going to make your life easier. So then we can say du dx equals 2 and du equals 2 dx. Okay? So far so good? Young, is that okay? All right. Now, so at this point, we're almost there, but we're not quite there. We can say that this is equal to this part here is like secant u. But then what's the problem? Well, what am I missing, I guess, as I'm saying? My goal is always to get integral of u du in some form, right? No. What am I missing, Mo? Well, just what I'm... Yes, Mo, but what I'm getting at is I need du, and du is 2x, or 2dx. Right now, right, I am missing a 2. Okay? So, basically what I'm saying is, what can I do to make this in the proper form? So I can say this is the integral of secant 2x squared. That's secant u. And then to have du, I need 2 dx, right? times 1/2. Exactly. So that way I just go 1/2 times 2. I've got 1, and it's the same as dx. It's just in disguise. Okay? And Derek was twitching over there, yelling coefficients. So then I can say that this is 1/2 times the antiderivative of secant u squared du. And there I have it in my basic u du form, and I'm good. Okay? Notice, I did 1, 2, 3, 4 steps, 5 steps if you count this, before I took the antiderivative. And a lot of times doing that prep work ahead of time makes your life a whole lot easier. And I know that's kind of, what's the term, antithetical to being a teenager, but go slow. Okay. So now, the question was earlier, what is the integral of secant u? Or the antiderivative? Let's ask a table. Sure. I'm positive we have that floating around somewhere. and you're right. We probably should, but we're not going to. What is the just straight up secant u, secant x, secant anything? Don't get crazy yet. Or secant squared u. That'd be even better. Look for a secant squared. That'd be even easier. Yeah, that'd be even easier. If you could find secant squared, we'd be golden. And I believe there is one. Tom? Yeah, and in fact, if you do that particular one, because what's a? 1, so it's 1 over a, which is 1 over 1, which is just 1. So that makes life really easy. So we have equals 1/2 times. Right. Right. So 1/2 tangent u plus c, and life is good. Nice find, Tom. Which one was that? 97? 92? So look on your table of integrals, number 92, and make sure that you can dig that. But wait, Mo. Oh, wait. We have to substitute back in. She's so right. Equals 1/2 tangent. What was u? 2x plus c. And we're done. Should we check it? Why don't you all take the derivative of this? Derivative to check. Check it out. I'm going to get ready for the next one. What are we up to here, Jeremy? 8 minutes? We're going to do another example. Huh. 1 over cosine. Okay? So we'll be okay. We'll be okay. All right, Jeremy. We're going to fasten your seatbelts, gang. We're going to do one that's a little new and different. Now, have you read anything about changing the limits of integration when you substitute? Okay, so that's what we're going to talk about now. So what if I have an integral, a definite integral from 0 to pi over 3, that interval of tangent x secant squared x dx. So this is similar to the one we just did. It involves tangents and secants, and that's on purpose. I wanted you to have a certain level of comfort while we get into this. So we're going to let u this time equal tangent x. So what's du dx? There you go. Equals secant squared x, and then du equals secant squared x dx. Now notice the reason I chose tangent x is because I knew that the derivative was secant squared. So after you do a bunch of these, you start to get better at making those choices. I saw that. When I saw this problem, bells went off in my head. I went, ooh, that's the derivative of that. And so that drives, that informs your choices. Okay? So then, Danger Will Robinson. Okay, and this is important. When completing a substitution on definite integrals, you may need to change the limits of integration. Yeah, not really. They
I'm just imagining it like some curve, like tangent it goes up to infinity, but it also gets smaller. How you because some curves this potentially that would have that's going to have a limit there.
right,
But
right. And you're right. You gotta. This can get messy, and you gotta be careful. Okay. So right now, we have u du straight up, man. We're golden, right? We are golden. But I'm going to say note. We're going u. We've got to look at u of 0, and we've got to look at u of pi over 3. U of 0 equals tangent of 0, which is equal to, no, 0. It's undefined at pi over 2. What is it at 0? All right. Tom, what's tangent of 0 at 0? Oh, I kind of gave it away. It's 0. Oh, man. Mo, is that what you're going to say? Yeah, it's 0. I gave it away. I'm sorry. So, what's u of pi over 3? Tom, I give you a chance to redeem myself because that was my bad. What's u of pi over 3? Well, that equals the tangent of pi over 3, which equals sine of pi over 3 over cosine of pi over 3. You remember this one off the top of your head? From Trig last year? Sine of pi over 3. Mo? Okay, on your unit circle, pi over 3 is up here. And it's 60 degrees. And it is tangent, or sine is square root of 3 over 2. What's cosine? Well, it's got to be less than 1, not 2 over. 1/2. Equals square root of 3. Derek kind of was a fish giver there, but he's right. It is the square root of 3. And that's no big deal. You can do that in your calculator. It's fine. But hopefully you recognize that it's the square root of 3 and not 1.7, blah, blah, blah. Okay. So, Jeremy, wake up if you've fallen asleep. I know this is heavy. So, our new limits of integration are 0 and square root of 3. So we can say now we have the integral of 0 to the square root of 3 and maybe I should back up. I'll do the original. 0 to pi over 3 of tangent x secant squared x dx equals the integral from 0 to square root of 3 of u du. And this is where it gets cool, okay? Because this is a definite integral, all I got to do is plug those in, and I'm done. There's no substituting or anything. Okay? There's no putting it back together. There's no, how Mo, last time you said, oh, I have to put tangent x back in. Because I already did this work here, all I've got to do is plug these values in. Well, I got to take the integral and evaluate it, and I'm done. And that's pretty cool. So this is equal to what? What's the integral of u du? U squared over 2 evaluated from square root of 3 to 0. That's it. How magical is that, man? Equals. Alex, haven't picked on you. Everybody else, give Alex a chance. No, we don't. We did all that work up here. We did all that up here. That's what's really cool about this. All you got to do is plug in these guys. Okay, so plug them in. Square root of 3 squared over 2. No, close. Minus, good, 0 squared over 2 equals 3/2. Okay, now, don't believe me? Which you shouldn't. Question authority, IEV, can't spell today, believe? Man. Yeah. Check by your TI-84. Check it. Plug in tan x secant squared x from 0 to pi over 3. And what's secant squared x for calculator purposes? 1 over cosine x squared for your calculator purposes. Okay, Jeremy, check that at home, and then tell me if I'm wrong. We're at 18 minutes and a half, and so I'm going to sign off here. And get your butt back here. And Colton, if you're watching this, I hope you had a lovely day at George Fosk, and we miss you, and we hope you come back soon.